Hello students, this is Ms. Mason here, and today we're going to review earthquakes and talk a little about the different parts of an earthquake. So as a review, I had painted a picture that could represent the San Andreas Fault. And remember the fault lines, the lines that it's like the fracture in the surface of the earth, or the location where these transform plates are interacting with each other. So there are fractures in the Earth's surface. And if I zoom in on a fault line, it would look like this. They're zigzag, they're interconnected. They're not just like flat. It's not just like this. Even though we were doing the transform slide, like that, I was kind of showing, making it look like they just easily slide. But in fact, it's more like this. It's more like a slide like this, not this. All right, so this is a zoomed in version. So an earthquake, well, here we have two plates. Let's say this is the Pacific plate, LA is on this North American plate, San Francisco. So right now, the North American one is actually going south and the Pacific one's going north. So this is happening, all right? It's just like this. But sometimes these interlocking parts get stuck right here. Let's say there's a jam, it's stuck, trapped. This creates a lot of pressure. There's forces here. A force is a push or a pull. So there's a force generated by those convection currents, remember, in the mantle to make these plates move. So this one is moving north, this one's moving south. Those are forces. One's going this direction, the other one's going this direction. Friction is a force that always goes in the direction opposite the force of motion. So if this plate wants to go this way, friction is pulling it this way. So there's friction in these interlocking plates. And sometimes, most of the time it can overcome the friction, so it just slides. But sometimes it gets trapped. So here's trapped, entrapment. And this builds up a lot of pressure. So it wants to move. But it can't. And then finally that pressure builds up and it is released. Alright, and that generates seismic waves. So that energy is transferred into seismic waves, and you feel that in an earthquake. It's the shake. Alright, so the shake right here. This thing's shaking. Okay? So that is really what an earthquake is. It's transform boundaries, two plates interlocking, and they get stuck. Right? And remember, these are plates that include the crust of the earth and the outer mantle of the earth. So the lithosphere. So in that lithosphere, there's different areas. It's pretty deep. So sometimes it gets stuck down a little deeper. Sometimes it's not as deep. And earthquakes, really, that have a focus closer to the surface of the earth are actually more destructive. The circles in this picture represent the waves, the seismic waves produced from the earthquake. They are not picture circles representing the earth itself. Ground line. We're going to say this is like the very exterior of the earth, the crust. Right? Here we have the fault line. The fault is like the fracture of the earth where the transform plates meet, or where they interact. Transform boundary. Alright, let's say this area right here is where they actually got stuck. So it was this area where they got stuck. That's called the focus of the earthquake. That's where it starts. That's where the waves are generated from. That's where the action is. Or it's called the hypo focus. Sometimes they just shorten it and say focus. But hypo means below. So hypo focus, it's below the very surface of the earth. And this depends on the earthquake. Some of them are lower than others. Some of them are deeper than others. All right, but it is not at the very surface of the crust. Directly above is what we call the epicenter. So this is on the surface of the Earth. And this is what scientists want to figure out. Where's the epicenter of the earthquake? Where did it start from? That wasn't the original location, but it was right above it. Okay, so the epicenter is the location directly above the focus. All right, so that's the area on the surface of the Earth that we look for. The hypo focus, or the focus, this is where the energy is released. All this energy is going to be released in the form of shaking, seismic waves. And they travel just like ripples on the pond, the surface of a pond. That's the way they travel. All right, so they go out, spread out from the center. All right, so these are called seismic waves. Seismic. And a seismograph is something, an instrument used to measure seismic waves. So I'd like you to try to make a seismograph. I'm going to give you a video that gives you some directions. You can do it with very minimal materials, so you don't have to go out and buy anything. Like a cardboard box, some string, a cup, and a pen is about all you need, really, to make a very, very simple seismograph. But a seismograph just indicates the amount the Earth is shaking. And that's how they measure the magnitude of an earthquake. So this is a picture of a Richter scale, which is actually a scale to measure the magnitude or strength of earthquakes. And earthquakes are measured from a range, a scale of 0 to 10. The highest actually recorded was a 9.5 in 1960, but the range is 0 to 10. And if you look at this picture, it's a logarithmic scale. So on the y-axis, as you go up each level, each number, there's 10 times the amount of shaking, or the shake is 10 times stronger, and it's about 33 times more energy. So as you go from, let's say, like a 3 to a 4 would be 10 times more shaking than a 3, and 33 times more energy than a 3. So it's based on logarithmic scale, and you can see that obviously a 0 to about a 2, you almost don't feel it. So earthquakes really are happening daily, and most of them we don't even feel. A 3 to about a 4.5 is minor, and then 5 small, 6 moderate, 7 strong, and then really when you get up to 8 or greater, it's a very, very destructive earthquake. But this is using a Richter scale to measure the magnitude of earthquakes. And generally, if the focus is closer to the surface, it causes a larger earthquake. All right, because those seismic waves can be passed through the crust of the Earth a little easier. So those are the parts of an earthquake, and I've felt a couple earthquakes here. I've been here 6 years now, and in San Jose, and I've felt a couple. I'm sure you might have felt a few yourself, but it's just an indication with the ground that you walk on is actually moving. So nature is awesome, and it's really even more awesome when you understand some of the science behind it. Makes it more interesting, makes it more fun. So hopefully you will find some fun in science, learning about science and learning about nature, how things happen, how does the world work. These are things that we want to know, and we need you. Scientists need you because you have a lot of ingenuity, you're creative, and you're smart, and you can do whatever you set your mind to doing, and scientists need people like you. So this is just a description of earthquakes. So this is earthquake lesson, and please answer the questions in complete sentences. Questions are posted in the YouTube video description. Bye, rock stars. I love you.